I'm going to level with you guys. I totally forgot to record some stuff. So I'm going to quickly go through this material for your notes so that you can have it going forward. We need to talk about the Cretaceous Paleogene extinction, which was the most recent mass extinction, excluding, of course, the one that is happening right now. So let's talk about it. The Cretaceous period was the time of the dinosaurs. This was when they were the most populous. All of our favorite types of dinos were around. It was between 145 and 66 million years ago. So 145 million and 66 million years ago. This is a dinosaur that looks a lot like a bird because dinosaurs and birds are the same thing, believe it or not. This is a microraptor on this image. It looks kind of like a crow with long feathers on its legs, excuse me, and long feathered legs and a long tail. So, but this is, an example of the type of dinosaur that would have been around during this time. And this was the time that they were doing their thing. Okay, 145 million to 66 million years ago. Around 66 million years ago, 65 million years ago, the dinosaurs went away. The ones that didn't become birds, at least. And there's this distinct line in the geologic column. So remember that that's the kind of the history of the whole Earth in layers of rocks. That the dinosaurs just go away. And I have the term non-avian here. Non-avian means not birds. So the birds made it, but the larger dinosaurs that would not eventually become birds did not make it. So this was a recent discovery. Paleontology is actually really just a few years ago discovered the reason why this happened around the time that I was born, actually, in the 1990s. So this was a big mystery of why the dinosaurs would have disappeared. And of course, during this video, if you ever need to pause to get down some notes, please do so, because we're going to be moving quickly. So at first, there wasn't enough evidence to support this idea that there was an asteroid impact that killed the majority of the dinosaurs. Now we know that that is the truth. We have a picture here of a couple, three paleontologists. This man right here, his name is Walter Alvarez, and this is his father. I believe his father's name is Luis Alvarez. And they're kind of similar to Alfred Wegener that we talked about with plate tectonics, in that their idea was initially dismissed, but then more evidence became apparent. So Walter Alvarez was the one that proposed this idea. And let's look at the evidence that supported his hypothesis for an asteroid strike being behind the extinction of the dinosaurs. Alvarez, thankfully, is still alive. Unlike Alfred Wegener, he was alive to see that his work was validated and accepted. First piece of evidence that I really want you to understand is the KT boundary, which is a layer of rock that can be found all over the world that has a high amount of a special element named iridium, right? And we can find this all over the world, right about 65 million years ago in the geologic column. So anywhere in the world, there are rocks that are 65 million years old. There is a layer that has this high level of iridium. What's important about that is that iridium is rare in Earth's surface, but it's common in asteroids. So there's this layer of rock all over the world called the KT boundary. KT stands for Cretaceous tertiary. And so you'll hear me say KT, KPG, or Cretaceous Paleogene or Cretaceous Tertiary. I know those are all kind of confusing words. They all mean the same thing. So KT, KPG, Cretaceous Paleogene, and Cretaceous Tertiary all mean the same thing. It's the extinction that the dinosaurs died, right? So KT boundary. This indicates that there was an asteroid that struck the Earth, making a layer all over the world that was high in iridium from this asteroid. So the asteroid exploded and rained down all over the world, made this layer of rock. All right? Moving forward, that's the KT boundary. More evidence was needed, though, to accept the hypothesis of an asteroid strike. Asteroids generally leave a crater, and this one is no different. And this right here is a map that was taken of the area, and this is a composite map that shows magnetic and gravitational anomalies in this area right here, just on the border or on the coast of the Gulf of Mexico. And this is called the Yucatan Peninsula in Mexico. This ancient crater can be seen if you have special scientific equipment. It can't be seen from space. Too much erosion and deposition of other rocks and so forth has happened, but we can detect that it is there. It's buried underground under many layers of other rock, but it is there. So this is called the Chicxulub crater, Chicxulub, which is a city here on the Yucatan Peninsula of Mexico, nearest to the crater. This was kind of the smoking gun of what killed the dinosaurs. You may recall watching the video and doing some reading about the extinction of the dinosaurs, and they talked extensively about this crater. All right. Quickly finishing up, we will just review. We understand that it was most likely an asteroid impact that killed the dinosaurs. And the evidence for that is a layer of rock that can be found all over the world called the KT boundary. It is high in iridium and is all found at 65 million years in the past, all around the world. And a large buried crater called the Chicxulub crater near Mexico that is the correct age and size to be the crater of the asteroid that killed the dinosaurs. I know this is a short video, but this should be in your notes so that you can have it going forward for your understanding and for the tests.